Hi there! What I have here today is a small LED lamp, battery powered, so for AAA's. We're gonna take a quick look here at it. Well, what it helped me with, it helped me diagnose the problem in the middle of the night. Recently, we have a lot of snow and ice melting. We finally have above freezing point temperatures, so well, it's very wet around here. So what happened is that the day after we had those temperatures, I went to my car and basically saw this. And after that, well, to be honest, I was really confused because the video I have put here was the next day, but I already had a problem diagnosed. So what happened there? There wasn't an oil leak, there wasn't a problem with the oil pump. Everything was working fine, but there was problem with the oil sensor, and I at first thought that I have to replace it, but. Well, what exactly happened is that water went into the connections to the oil sensor, so it will all went crazy. So that little lamp helped me diagnose this. It has let's see, 16 chips here, so it is fairly bright, and you probably can find this in a different setups from a different companies that's made in Auchan. So that's a French supermarket. It has a magnet, and what we all we have here is a battery cover, and those are the batteries it came with. So I'm just quickly wondering, are those even in a fairly good state? It does say they are alkaline, but well, they at first look they looked like a zinc batteries here. It does say here it's almost 6 volts. If they would be new, that would be a little bit over 6. So let's take a look inside how they have the voltage drop, because obviously those 16 chips, they cannot be driven directly from those 6 volts. Let me just quickly unscrew this. I think it isn't clipped anywhere. You just can pull this off, and there is only a reflector and the stand with the magnet. So let me oh they went really with the easiest solution here, which, I mean, I guess it's good, but at the same time you're losing a lot of current over this big resistor. So if I turn this on, and yeah, that LED here, I mean the chip, does it have some kind of, no, it doesn't have any heat sinking. That's a aluminium backplate, and it runs at 250 milliamp, 250 something. And at the same time, when the let me switch to the volts, and when the LED is on, I was curious how much does drop the the resistor drops 2.6 volts, which is I'm not sure you should be able to see now, which is quite a lot, because at 250 milliamps, 2.6 volts, what's gone here is 0.65 watts, which is quite a lot of voltage. Because does it make any sense to drop as much? It would be a better idea to run this using 3 batteries. Because if you think about it, if I bridge one of those batteries, it will mean that voltage drop will be lower over this resistor. Oh, it's quite hot. Oh, that's really bad. Whoa, I didn't expect it, because I was just using that for, I don't know, 20 minutes. It was in the enclosure here, and it gets really hot and toasty. I surely cannot hold it. We had a 2.6 drop over the resistor, because the voltage of all the batteries, there are 4 of them, 1, 2, 3, 4, would drop. Yeah, that would be a significant drop. So it would be a complete heat loss, and so on. But And those LEDs, because they were all in parallel, were driven at 2.85 volts. Okay, so what I have here, if you take a look at here, I have 120 something milliamps, but one thing to note, I don't have a, and what I did here, to be specific, in that setup I just showed you, I did something like this. So we have also 4 batteries, four AAAs, but they do not have any resistor at all. So they are connected directly, they are supplying, well, in the without anything 3 volts, the 3.1 sometimes if these are new, but actually under the load they are supplying 2.75 volts under the load of the LED, so times 16, and so you know they are all in parallel. So what exactly happens here, there is no resistor, so there is no direct heat loss, and those LEDs have those batteries, because those are, well, they are not great, and they have their own internal resistance, so they cannot supply a perfect voltage. So they run the circuit. This was about 250 milliamps, and this is about 120, let's call it 25, half of the current. Keep in mind, this would be, I don't know, maybe 2/3, 3/4 of the brightness, because the thing with LEDs is you have to drive them at quite a high current, so to achieve the much higher brightness. So that this would mean that this isn't a significant loss of brightness. I would call it 2/3, let's say, to be on safe side. And at the same time, one thing which is important, you don't lose the power on this. So if this is a LED, battery driven device, that means a very long battery life for this lamp, because so basically it can supply twice as much time just by a sole part of this sum of the two sets of parallel batteries. So that's already a twice as long lifetime, and if you drive this as a half of the current, it means that in total it would be 4 times as efficient, and let's call this that it's at 2/3 of a brightness. And so now quickly, why they didn't do this, because obviously they could go ahead and claim a bigger battery life. So for example, we have comment over here, this one, which has voltage of 1.527, this one, which could have voltage of 1.126, and let's call those 3.1 maybe in total. So what we have here is a 1.511, and here we have 1.55, so 3.05. And what would happen, because this is higher in voltage and this is a little bit lower, in this setup there would be a current flow here, so they would basically, if you stop looking at this would mean that they would start flowing with the current flow. So those batteries that have a higher voltage would start trickling down their current towards those that with a lower voltage, until they would balance themselves, and then it would stop. But if one of those would start to fail, for example this one, and it would start to drop, because, for example, chemistry isn't perfectly right. After the balance, it would start to drain those batteries, and this one too. So overall, it would start just discharging this whole set. So even though you have of continuous use 4 times as long battery life, you would have to disconnect here at this point and at this point. So you have to have a double switch basically to make sure that there is no current flow between those. That's why the company wouldn't do this, because they want to have the feel of the product is great during normal usage. Yeah, battery life isn't as visible to the customer as something like draining the batteries over the time when this is just lying somewhere. And if you would like to use this without any kind of 4 cells like this, just use the 2 cells in the let's call it 3-volt arrangement. All you have to do is, because here we have a connected plus to the battery, so instead of here you would connect the switch here and connect it directly, skipping the resistor. So try and that would be here. So that's the brightness, which let me compare this to full brightness from a whole 4 battery set. There is a significant change in the brightness. So this and this. This video was supposed to focus on the improvement of the factory setup, so I'll show you exactly what I did. So I decided to remove one of the batteries and decrease the resistance to make sure that the current is still quite high, so it will still run brightly. So I connected additional 2 resistors. That's a 1/4 watt one. So you could think that that's far too low, but I will skip this connector and connect the button directly to here. So I'm done here. Only 3 batteries, and it still works. Oh, it should. Yeah, it still works. It has quite a bit of brightness, and let me show you the current that's going on here. I switched the switch connector from here to here to keep those 4.5 volts in total from the batteries. So that should be roughly speaking here almost 4.5. But once you turn it on, there is a significant drop. So here you have it. 3.9, so it drops significantly. The voltage drop over the resistors is actually 0.88, let's say, so not that significant. The voltage on the cap is very similar to before, 2.87 as opposed to 2.85. And now for the current, let me try and show you exactly. And here we have it, 310 milliamps. So that should be quite a lot brighter. The resistor before, with the 4 battery setup, had a voltage drop of 2.6 volts, and that was at 250 milliamps. And this roughly equals to 0.65 watts. So that power went basically nowhere to heat this this resistor, and that was it. With current setup, I have a voltage drop of almost 0.9 volts at 300. Oh, that should be 0 here. 310 milliamps. So that's roughly is 0.28 watts. So there is an improvement here, at least in the battery life terms. That should deliver quite a better battery life with a lower number of batteries also, and a higher brightness. So that's what I think it should deliver, at least. And the main improvement here is removing one of the batteries, skipping quite a bit of voltage drop over the resistor, and keeping it cooler also. Yeah, that's a 1/4 watt resistor, so that's not exactly too good, but some of the current will go through the bigger one, so I wouldn't be too worried about this. All I have remaining is to put it back together. Make sure to noted that this this is intentionally left blank and no battery will go here. Maybe I will remove this connector here so I can remember better. And that's it, guys. Thank you so much for watching. See you next time.